Here what we are setting up today is actually all the supporting structure, the aluminum I-beams, and we have to make sure they're absolutely leveled through the entire range of the I-beam, from the wall to this wall right here, which is almost 25 feet. We have to make absolutely sure that this I-beam is perfectly level. The steel bars that we made before we came were actually precisely measured and built to support the I-beam in 3 different locations.
We have a set of risers that actually attach to the beam that bring the entire system down about 4 inches. All of the electronics that control the actual readout for the screen live above the rails. So what we want to check and make sure is that even with the risers installed, we have enough clearance that we don't hit our braces. Because all the electronics actually live on the carriage that moves back and forth. So we're using an I-beam to support the system, and the reason I-beams are shaped the way they are is because they're really, really good at supporting load underneath them. But we do want to brace the beam on the side because they're not as good as taking loads horizontally. So we run braces to the wall so that any input from the user doesn't cause the beam to want to swing or twist. And also another reason we do it is because with such long supports to the ceiling, without bracing the beam laterally, we're putting a lot of stress on those bolts. So by preventing the beam from being able to swing, we're essentially taking away that big wrench. Brace across also just to kind of keep the whole structure together. That way we're distributing kind of everything over the entire installation instead of having points where we're relying on a single support. This is the bottom of the beam. We don't see the beam here. Here we have the clamp on one side and the other side. That's how we lock the entire system in. On the right here is the top of our carriage. That's where all the electronics will go eventually. So we're checking really to see the difference between this surface and this surface to make sure that any lateral bracing that we put left to right across the screen isn't going to interfere with this little shelf that we have for the electronics.
If you look at the bracket from the other side, it has a pivotal point, and they can be adjusted on each side. When we actually mount this bracket, screws directly on the flange of the I-beam, and we can adjust this part, the upper part of the bracket, independently from the bottom part, which is attached to the plate supporting the rails.
You're welding this thing?
Every single bolt that we use, they're all Allen. That allows us to have a very secure, tight attachment. Once we secure all those leveling brackets, each section is mounted to the I-beam, and then we make sure they're tight against one another. Then we secure it to the I-beam. Then we level each one of them. Notice in the middle here, this is actually an aluminum bracket that will support the encoding strip.
Of course, there's 2 sides to these clamps. Take all of one side off so that we can actually get the whole system up to the beam. What they're doing now is they're putting the second side on and come down by putting one of these back on.
We're tightening the leveling bracket to the I-beam on both sides, and then we'll put a level between the rail in each section and level each leveling bracket individually. We're also tightening up a safety bolt, if you will, that prevents it from rolling back.
Don't cry. So we spent the last couple of minutes loosening up all the brackets. That way we kind of can adjust the level. The way that these work is there's a pivot on the back side of this clamp here. And we have kind of a seesaw action. So if you have two kids on your seesaw here, if this kid extends his legs, it's actually going to bring this side of the rail up, and then vice versa. We're also taking a stainless steel screw into an aluminum bracket. So we do get a little bit of a bite on the aluminum. And then we just counter tension them so that they push against one another. And we'll do this for every single bracket on the system. The reason we want to do that is that these beams aren't necessarily straight along their entire length. They can even have a little bit of a twist along the system. So we can kind of compensate for that entirely without having to sit here and get the twist out, which can be a pretty tedious process. So we want to make sure that we're level across the entire travel of the system. If you're checking your lens close, middle, or far, you don't want to have to adjust the camera tilt and pan in order to get your frame, on the chart again. So if you're not careful about how level the whole system is, as you move your chart farther and farther away, it may shift in the frame of the camera. And then actually once we put the carriage on, we're going to do another leveling of the chart itself. And we'll guarantee that at each location along the system, we have a nice level chart that's going to stay where it is in the frame as it moves.
Oh yeah, but I heard it's not a good blade.
So the carriages have a left and a right side, and when we're facing the operator, the belt and all the electronics will eventually exist on the left-hand side. Let that hang for a minute. The column goes on next. It's actually designed so that one person can do it. There's these little retaining flanges on top. Slide it forward, it'll stay in place so that we can get the screws in it. This is the bridge for the light and the monitor. It sits down on top, and there's 4 screws. Take the tension out and get them over the top here, and then retension. For now, tension is not super important until we get the entire load onto the system, including a light, monitor, chart, all of the cabling. So we'll just make it taut for now, and then we'll adjust visually later just to take any sag out of the front of the system. All right, next up is the chart frame itself. We have different size rods depending on the height of the installation. This particular installation is pretty tall, so we're using our longest 12-inch rods. They're going to thread up through here into the plate on the bridge, and then we're going to use 4 screws from the top to lock it into place. If the chart ever needs to come down for an event or just need to get it out of the way, you just drop these 4 screws, kind of reverse order, and just pull the chart frame out. If you have a couple people, you can actually go ahead and just pull the column itself. And then there's an adjustment for height here in front on the column. What we're going to aim to do when the pedestal's all set up is to bring the center of chart in line with roughly where the camera would be with a normal sized head. And then the user obviously can adjust fine amounts to get it right where they want it. So we're going to put the hard stops in so that the actual carriage can't leave the rails. They have 2 screws underneath them, and you'll notice we have kind of a auxiliary rail here that has just a bunch of mounting hole locations. So if you have a client who's testing a longer lens, you want to make sure that the chart can never run into the lens, you can actually sneak these forward and stop the carriage before it can get that far. Right now, since we're just setting up, we're going to put it all the way over, get as much travel out of the system as possible. But it's just 2 screws to adjust later down the road, pretty easy. I'll show you the bottom as well.
Awesome.
You want to make sure that the rubber end ends up above the rail. So You don't want to put it on this side where the rubber ends up inside. You want to make sure that that rubber ends up right above the actual rail that the carriage travels on. If you really need to alter the travel of the system, these rails are actually removable and they can be placed at any location. So, you know, if you have a bunch of equipment and you want to limit yourself to half a lane, you can actually put these in the middle of the system as well. But typically they're at the end so that you maximize the amount of travel that you have. When the carriage comes forward, we stop right against the wheel holders. And what we can do also is we can make some adjustments in front. There will eventually be a monitor and potentially a light here, so if you have obstructions that you don't want to hit with this, this is also adjustable fore and aft. A lot of times also, if your light is not giving you an even throw onto the entire chart, you either want to bring it closer or farther away. So the 3 screws up here, you just loosen them up, helps to relieve a little bit of the tension first here. Now you don't want to go all the way loose with these because you'll end up losing the nut that's captive inside of the extrusion. So you really just want to do about a quarter a turn. Alright, so now we can adjust fore and aft. In this installation we're actually going to bring it quite a bit forward so that we don't risk hitting the far wall with the rear end of the bridge. But we'll do the same setup on the other side with the stops so that we end up hitting our stops before we end up touching the bridge to the wall. Yeah, okay, so this is the tensioning mount for the motor system. We have these intermediate plates at both ends of the system. They have kind of holes on either side. Any belt accessory that we sell are going to mount to these. So we have a hand wheel accessory, we also have a motorized accessory. We're installing the motorized accessory here today. So we are going to mount to those plates. 3 threaded holes on top here, they correspond to 3 through holes on the plate. We have screws that come from the top. You'll see again later, but the motor's going to plug in here. This whole thing slides so that we can crank the nut at the back and put tension on the belt. We have about 6 inches of travel. Periodically, you know, since we have such a long run of belt on this system, it'll start to just stretch over time. You'll just come back and do a couple turns of this nut to bring that tension back out. And you don't want to over tension. We can talk about that when we get to the belt step. You just want to make sure to kind of take the slack out of the belt so that there's no risk of it slipping on the cogs on either end of the system. Yeah, that's the oldest blue. So generally what we do is we set them up so that they're kind of together, but then once it's on the system, we make sure that the frame is centered and also level.
You want me to slide it in? Find the computer system. It's on.
We're mostly going to be shooting this way.
Yeah, so this.
Yeah, this is the this is
Okay, there's 3 pieces of electronics on the carriage of the Opti-Glide that we need to be concerned about. First one is a Windows 10 PC, which is this black box here. Next one is our MightyWorks circuit board. This is what's handling the communication between all the accessories on the system as well as reading the encoder, and then our monitor. So all 3 of these electronics are always on the carriage. They move with the chart to and from. And so the cabling is important. We need to make sure that we get all the cabling that we need into the cable management system so that it can hook up to the carriage and we can drag it along. Both of these units are 12 volt power, 12 volt DC. We provide the power supply. So one of the main cables in the management system is just going to be an extension cord. There's going to be a 3-prong outlet on the carriage itself, one for the computer, one for the monitor, and then one as an accessory if you're running a light. We are going to do monitor power, monitor HDMI, and then we also have a USB extension cable so that you can communicate with the Windows 10 PC without having to jump up on a ladder. All right, so we have a monitor power and monitor HDMI. We use the channels here along the bridge to kind of stuff the cables, keep them out of the way. And then what I usually like to do is I take the female end of the USB extender cable and I kind of piggyback it right there. We provide a wireless keyboard and mouse, and it's a Logitech brand. It has a little dongle, so when you need to administer any changes to the computer, you can just kind of put the dongle behind the monitor and start controlling the computer. Okay, and then with the excess for the time being, while we work on the power cable, we're just going to run it back through the center of the bridge, just kind of like this. For now, we'll do the same with the power cable. So you just want to leave a little bit of slack at the end here so your users can adjust the angle of the monitor and you don't tug too much. All three of them are going to go up to the top of the carriage. So we mentioned before we have the Windows 10 PC in our circuit board. They're going to live right here. So all these cables are eventually going to get up there. In the meantime, what I like to do is kind of just make them a nice little bundle. And we'll go ahead and zip tie it every 6 inches or so. So the idea is that these will come up as a bundle. We want to leave a little bit of slack here so that if we adjust up and down, we're not tugging too much on these. And what we'll also do is we'll take a little sticky and kind of tie this down so it can't get caught up in any of this mechanism. So we're going to mount the motor from the bottom. It's not mandatory, but it's definitely helpful to pre-loop the belt and kind of feed the pulley up through it. That. There are 4 screws that come from the bottom into the tensioning assembly. And we generally, for cable management purposes, put the ports of the motor facing away towards the back of the system. You can next feed the belt through. One end, this end is going to go to the carriage. So you have the outside face of the belt, that's going to go to the carriage. The other side is going to go all the way down to the other end of the system, but you want to make sure to get this to go over the top of the carriage. This piece that wants to go above, in between the plates and the carriage. If it's underneath, you're going to have a bad day. I usually like to put the teeth of the belt belly up so that I know I'm not introducing any twist. And then at the carriage itself is a belt clamp, which we can put the end in. It's toothed, so you want to make sure that the teeth of the belt are facing inside. You'll actually feel it positively engage with the belt. And then if you clamp it down good, it has nowhere to go. The motor will feel extremely uneven when it's not powered. That's totally normal. Yeah, I do. So again, making sure we're belly up just so we don't have any twists coming towards us. We're going to feed from the inside out. The recommended way of doing this is very similar to the other side. You would want to drop the 3 screws out here, pre-form a loop, plug the whole thing back in and tighten the screws. I'm going to try to get around doing that by kind of pressing the belt in and then manually turning the pulley with my thumb. Tighten up. Okay. This is the end that we refer to as the idler end. So the motor is what's driving the belt. This side is just idle and will just turn with the belt as it moves. So if, if we ever say go to the idler end or go to the motor end, this is the idler end. Okay, so when you're sure that you have all the twist out of the belt and the belt's running straight, you just want to go ahead and kind of pull it taut, like this. And we're going to go ahead and cut the belt excess off, right about there. So we just are going to loosen up the belt clamp on this side now. Pull this in. Again, with the teeth facing the inside of the system, because the belt clamp is toothed, we want to make sure that we engage the teeth. The belt is not a continuous loop because it's so long. So we have one end that stops at the first clamp, goes to the motor, loops all the way back around to the idler, comes all the way back around to the carriage, and clamps on to the second part of the clamp. So these guys are independent. You're going to have both ends of your loop end up at the carriage right here. And you'll notice we're still a little slack, but that's okay because the next step we're going to do right here is to pull that slack out. More tension out so I can illustrate what I'm trying to say. In order to add tension to the belt, we want to try to move the motor farther away, right? We'll draw the slack with the motor backwards like this. So in order to do that, if we tighten this nut, it essentially pulls the motor towards the nut. And by doing that, we can add tension to the belt. Now, what you want to do is kind of watch the belt as you do this and make sure that the belt just starts to kind of stand up on its own. You don't want to over tension it. There's really no reason for it. So if we tighten this, what you can do is kind of push it, take up the slack, and then give this a couple turns. All right, normally you'd use a box wrench for this, but we don't have one handy at the moment. And then if you look down the run of belt, you see how the belt is now just starting to stand up on its own? That's kind of what we're looking for. If it's a little bit sideways like this, it's not the end of the world. We don't want it so taut and vertical that you're putting too much stress on the bearings in both the idler and the motor. So kind of just loosely, just starting to stand up on its own is good, right about there. So we talked before about the two pieces of circuitry that live on top of the carriage. This is where they actually sit. So this will get mounted up to the actual rolling part of the carriage. We have the PC on the bottom and our circuitry on top. They're just going to be Velcroed together. So for serviceability, if you ever need to get them off. If you need to update firmware, it's going to be on this device, and we'll probably talk about how to do that later. But these two things communicate over USB. So we connect the USB micro on the Mighty circuit board into the PC below. We actually also power them off the same power supply, so they have a little Y splitter here. Again, that's a 12 volt DC supply. And what we're going to do is put the supply on here. We'll probably Velcro it and then kind of put a zip tie around it to keep it all bundled up. We'll just try to shorten everything up as much as possible because it's really easy to catch loops on things up there. So it's best to keep them out of the way. Other ports of interest on this are going to be the HDMI port for the computer itself. That's going to come off the monitor and plug in there. On the side, we have two more USB ports. So the extra USB extender that we installed behind the monitor will go in there. Power button is there as well. That's a good one to remember. As far as our circuitry goes, we have an input for the encoder itself. That is this multi-pin connector on the front here. And then we have an RJ45 jack. Now, the thing to know about this is it's not Ethernet. It's not internet. It has the same cable, it has the same plug, but it's not internet. So don't plug this into the router. Bad things will happen. First step here is we want to make sure we have the extension side of the extension cord, the female side, so that we can plug in. This is going to live on the carriage. As I mentioned, we're going to have one for our computer power, one for our monitor power, and then an extra one there for a light or any accessory that you want to mount. Usually about 6 inches or so. This length is fine. You don't have to do too much more than that. And then we want the Ethernet, which is going to be the communication cable from the main Mighty circuit board to the motor and to the keypad. Again, about a foot's fine. These are pretty easy to pull back through if you have to, so nothing is set in stone. So the first thing we want to do is kind of this is where the cable management guide anchors to the carriage. And we want to just be kind of in between two static plates so that we can press down a little bit. It helps to be able to sneak the cables underneath here. So we're going to sneak them underneath and they're going to come up on the other side. And then we want to try to clip the male black pins that you see here to the holes on the anchor point inside. So there we go. Okay, so now you'll notice if we move the carriage, we have the cable chain dragging with it. That's what we want. So the next step with our prepped platform here, we have a big window. We're going to feed both of these cables through that window. Okay, and then there are 4 screws that we then mount this. Okay, Ethernet cable is then going to go into our circuit here, and we will just clip it down. Right, and then like I said, what we can do is kind of back pull some of the slack out. We don't want to go too tight, but just to get rid of the loop. Okay. Next step is to bring the encoder cable that we have. Let's get that guy undone. So the encoder lives in between the carriage and the plates, the support plates. All right, so there's that multi-pin cable. That's what comes off the encoder. We're gonna plug that in.
Got it. Thank you.
So this is going to come up from the outside of the carriage, right? We'll button this all up in a minute. I just don't want you to confuse having it have to come through the window. So really, the only things that come through the window are the things that the chain management is responsible for.
Gotcha.
If you have a BNC or something in the future, you're going to want to have it pop out this window as well. But this guy plugs in. It only plugs in one way. You can't put it on backwards. So now we can take the bundle that we created before. We have one for monitor power. We have our USB. And we have our HDMI. So let's plug the HDMI first. Okay, that goes into the PC. And then we can clamp it in front here. There we go. We can start to plug some of this stuff in. So let's power the computer. So ultimately, we might look something like this. I want to do something like that. HDMI, we can kind of bundle up with that. And then the USB, we're going to sneak around to the other side where there are the 2 auxiliary USB ports.
This one's ours.
It's really important to use this right angle adapter. If you don't, the USB will tend to stick up and catch the support braces. But with the right angle, there's just enough room for it to sneak by. If it does, keep. It's looking pretty decent.
Pretty decent.
We're getting closer at least. So this is just a Windows 10 PC. If you ever need to get a menu up on Windows, you just hit Alt. Okay, it's small. It's meant to be, you know.
In the corner.
Yeah, so you can go to File. Oh, I just selected by accident. There you go. And then Settings. The other thing you can remember is Control Period. So if we're just in the screen and we do Control Period, we get to our settings. And then distance calibration is the very first one. That's the one we just talked about. There's 3 other settings. First one is invert direction. That one you're not going to have to worry about, but essentially what it means is if I push this farther away and the number gets smaller, we need to invert the direction. But right now, we're going to set you up so that the number gets bigger, farther away. You're not going to have to worry about it. The next one is precision level. So that's the number of decimal places we're showing. So right now, you'll notice that we're saying 1.4 inches. If we go back into our settings, right, we can go to 2 or 3, and now you're showing more decimals. If you do like shortcuts and can remember it, the 2 braces here, if you hold control, you could do more or less on the
So
fly.
control
And then the 2
left brace is less and the right brace
exactly.
is more.
But if you forget that, it's just in the settings, and you just come up here and you can click it back down.
Cool.
Either here, right, where we're just